Professor Synolakis, would yourself please present you for the audience?
I'm Costas Emmanuel. I am a professor of coastal engineering and natural hazards, and my permanent home is the University of Southern California in Los Angeles. I work with large waves, tsunamis, extreme waves, and in the last year, I'm on leave, and I've been spending my time in Greece as professor at the Technical University of Crete, and also as director of the Hellenic Center for Marine Research, which is the big national oceanography laboratory of Greece.
What is the origin of tsunamis?
It's a very interesting concept. I think the older world was tidal wave in English. Tsunami we started using it only in the last two decades because it was more catchy. But tsunamis captures the way that most tsunamis happen. They're observed as unusual disturbances in harbors, hence the Japanese word tsunami, harbor wave. Because in Japan, you get a lot of fairly moderate earthquakes that do not produce tsunamis like the one we saw in March in Tohoku in Japan, but tsunamis that disturb the ports. And because for centuries, if not millennia, people actually lived along the coast, in small ports. I mean, this is the only reason to live along the coast. Otherwise, you lived up on the hills to protect yourself from pirates. So the observations they had, they would see these unusual waves inside the ports that typically generate very strong currents. And since there were no storms or there was no wind, they would call this tsunami. And eventually the association was made with a big earthquake that will produce these very strong currents, even for small events. And of course, you have the very big earthquakes that produce very big tsunamis. At the same time, you also have volcanic eruptions that can produce tsunamis. And the really extreme events, such as bolide impacts, you can have meteorites that fall on the Earth, and this produce really big tsunamis. The tsunami, there's an interesting story there. I mean, and my view is that we exist because the dinosaurs don't. If the dinosaurs existed, I mean, we would have been, maybe we would not have evolved. And the dinosaurs disappeared because of in the KT explosion about 55 million years ago, and that left a huge crater. An interesting story is that the crater was actually discovered by inferring its position from the tsunami deposits that were found almost 150 kilometers inside the coastline of Texas. So tsunamis have been with us for a very, very long time, and they're likely to be with us for a very long time in the future.
So the tsunamis could be very, very big for example, when an impact comes, but they could be also smaller, for example, when they are originated by an earthquake or something like this. Maybe some rockets fall from an island into the water, something like this.
Yes.
All this can be the reason for tsunamis. So, what is the most recent reason for a tsunami? I think earthquakes, is it right?
In the last decade or so, we have seen a lot of tsunamis triggered by earthquakes. In 2011, we saw the Japan Sea tsunami. In 2010, we had the Mentawais tsunami of Sumatra, and then we had the big tsunami of Peru. And but we have also seen in the last 13 years tsunamis triggered primarily by submarine landslides. These are submarine avalanches, just like the avalanches in the snow, that they take place on soft sediments underwater. And typically the avalanche or the submarine landslide is triggered by what could be even a small earthquakes, a little bit of shaking of the sediments, and it just goes. Very much like an avalanche that you never know exactly the precise trigger, so you have avalanche control so that you can you don't get people into danger. So these landslide tsunamis are fairly, maybe they happen, large landslide tsunamis once every decade. Now we understand that earthquake-triggered tsunamis happen on average, once every 1 or 2 years.
Tsunami waves are not very high. You are a specialist for high waves, but the destruction is impressive.
That's a very good. That's a very good comment, because they're very different than what we call the extreme waves or the rogue waves that sometimes ships encounter in the open sea. And they get, I mean, a good example of an extreme, of a rogue wave, was the wave that was in a Hollywood movie called The Perfect Storm. Tsunamis are different. And the tsunamis in the open ocean, they're fairly small. To give you an idea, the 2004 tsunami of Sumatra, that was generated in Sumatra and then impacted the entire Indian Ocean. In the middle of the Indian Ocean, its height was about 40 to 60 centimeters. From 40 to 60 centimeters, it reaches Sri Lanka, where it becomes, in some places, close to 11 meters, and then it reaches places in Somalia and East Africa with heights up to 8 or 9 meters. Because what happens is that the wave is very, very long. As it approaches, and very small, as it approaches the coastline, the wavelength, think of the wave like this is the wavelength, the wave starts becoming shorter, and then the height becomes bigger. This is what we in English we call shoaling. And as the height becomes bigger and the wavelength becomes smaller, then you get waves that have really very large heights hitting the coastline, but at the same time, they're still long. This is why a lot of times surfers think that 10-meter tsunami, what is it? I mean, in the north coast of Hawaii, you have 10-meter waves on a good day. That's a good day for surfers. So what's a 10-meter tsunami? Well, the difference is that tsunami, even though the wavelength becomes shorter, it may become shorter from about 50 to 100 kilometers, becomes shorter maybe to 3 or 4 kilometers, but still a really big wave versus the 10-meter waves in Hawaii that may have wavelengths of the order of 100 to 200 meters. So what really makes the tsunami very destructive is that you have this almost mountain of water. Just think of something like this, a few kilometers long, if you're lucky, if you're not even longer, the height up to 10 meters approaching the coastline, and then it just penetrates inland and creates the destruction that we most recently saw quite live actually during the Japan tsunami in 2011.
How deep could they go into the country if it's flat?
If it is an asteroid impact, it could be 100 kilometers. Again, looking at what happened in 2011 in Japan, 4 or 5 kilometers. It just depends on the size of the earthquake or of the triggering event, but also on the topography. If you have a fairly flat land, the tsunami will penetrate quite a bit, inland. If the coastline is very steep, then the tsunami is not going to penetrate, as much. So it's all a question of the size of the earthquake and the steepness. For example, had there been tsunamis in the North Sea, and I mean, there's only one we know of from the Storiga slide about 6,000 to 7,000 years ago. Yes, it would penetrate quite a bit inland, but typically, as far as in Europe is concerned, when we have in the Mediterranean, tsunamis, I mean, the coastline is not as flat as it is in Northern Europe. So tsunamis don't penetrate, as much. So Southern Europe is lucky in that way.
How can past tsunamis be detected?
This is one of the holy grails of geophysical research. We have very few. The historic record in most places in the world is very short. For example, in the Mediterranean, maybe the historic record goes back, to the 2,500, 2,800 years before present, the written record. But in most places in the world, for example, the west coast of the United States, the historic record is only 200 to 300 years old at best. So we have to rely very much on geology and actually on people that look at sediments and on archaeologists, because just looking at the past and looking at excavations and trying to find clues of a tsunami, this is the only physical proof that we can have. Even in places such as the Mediterranean, where, as I said, there is a historic record going back to 2,800 years ago, a lot of small events are missed entirely. They're not there. Depends where the chronicler was, what they had heard of. Even as far back as 600 years ago, it's extremely difficult to know what happened. So we have to rely very much on geologists and archaeologists to give us information as to the impact of a tsunami, so then we can try to identify the type of event that produced it.
In the best case, you find some accumulation of material brought from a tsunami into the landscape, I think. And what about the Santorin explosion? As I see from your name, you are from Greek origin, and I think Arthur Evans was the first who mentioned the destruction and the dawn of the Minoan culture and connected it together with a tsunami or a volcanic eruption. And what about your idea?
Do you want the lecture or a short answer or something in between?
I want a lecture.
Okay, well, you asked for it. So, Santorini remains to this date a puzzle. There is no question in my mind that the big tsunami was formed. There's no question that it had impact on Crete and in the entire Eastern Mediterranean. The question is the size. But you asked me first, how did I get into it? And indeed, being born in Greece, and my family is from the island of Crete. I still have my grandparents' house in Chania, where I live when I get there. So as a little child, I used to go to Heraklion, which is about 150 kilometers from Chania, and play in the Minoan Palace. I remember, little boys can be very self-centered, wanting to sit on the throne of Minos. This is a stone chair, in the palace, and you go in and you sit there, and your parents take pictures, and you see yourself in a different era. And of course, at the time, the story that everybody heard was that, this was the volcanic eruption of Santorini, big tsunami came in, destroyed it. So this was my first sort of exposure to tsunamis, even though not by that name, but by the name of the tidal wave, which was a name that Thukydides, I think, had used. I'm not 100% sure if he actually said it as tidal wave, but he had described the big tidal wave during the Peloponnesian War that had destroyed the fleet of the, I think it was the Athenians. Anyway, going back to Crete, and so I knew the palace, and I was trying to understand, how could this happen? You see, you hear of this thing. At the time, I was not even sure what a big flood was, because in Greece, we don't really get, big floods the way that you can get from a hurricane, or for that matter, what you get, occasionally in Central Europe when you get big river floods. So it was something that was just not there. So the picture of the whole thing being destroyed by a wave, it didn't make sense. Advanced the clock maybe about 15 years, and then as a PhD student in California, I was offered to work on the run-up of tsunamis. By that time, the name tsunami started being used in the scientific literature, but not as much. I still have papers that I have written.
So the science of tsunamis is a relatively young science?
Well, absolutely. It is a very, very young science. If you take away Marinatos' work back in 1939, where he wrote in Antiquity, a very famous journal, and he made this hypothesis, that he connected the dots, if you will, and he found some sand on top of a wall in a villa in Amnisos in northern Crete. And he made all these inferences about having a tsunami, having the Minoan, the late Bronze Age eruption, creating a tsunami, destroying Crete. So I come into it from the point of view of pure curiosity, and my background is really hydrodynamics and trying to understand how can this be possible. But I have to rely very much on archaeologists because it is their view. For example, and I'll give you another example from Palecastro. They're the ones who know the site and see what it is. For example, Palecastro is a site in eastern Crete. There's a palace there that was, we believe, destroyed by the tsunami, and the walls have fallen down. Typically, old houses, if you don't do anything to them, first the roof collapses, then the walls cave in, and you usually find everything pretty much in place. Over there, it had been sort of wiped clean, and then there was a debris layer that was all of it was mixed up. This is information that the archaeologists find when they dig, and I mean, it's extremely interesting to actually look at their notes to try to see how it looked like the moment that they uncovered it, not when it was all cleared, because to expose the site for visitors. Because these are the critical clues, give us an idea that we try to understand. Was it a tsunami? Was it a big flood? It could have been a flood that came in from the mountains, or a river flood that did it. Flooding doesn't necessarily come in from the water. So the direction to which the walls have blown, the direction where you find additional debris. Just think about this. I mean, tsunami comes in, wipes things in, you find building debris. There's a debris, what we call debris wake, behind the tsunami. On the other hand, you can have multiple waves that take all the cultural debris, the broken pottery, etc., that mix it all around, and you have a debris layer. Usually these things are, if you find it now, you're very, very lucky, but they've been cleared. So we rely a lot on archaeologists' notes, intuition, to tell us what the site looked like when they first found it.
So, Professor Synolakis, when Marinatos wrote in 1939 about the idea that the tsunami could destroy these palaces, this was totally new and a new perspective on archaeology, but also on the destruction with tsunamis.
It's a very good point, and part of it is that Marinatos was way ahead of his time. Reading his paper, I mean, one really understands his real size about this big versus a giant that is that can make this incredible synthesis. One of the reasons that was very controversial, even in the hydrodynamics community, is that people were not convinced that always tsunamis deposit sediment, even though to us now it's obvious, because a lot of people believed that tsunamis cause substantial erosion in the coastline, and in fact that also happens. And only in the last 2 decades that tsunamis have started happening fairly frequently, and we have been able as scientists to observe the effects of tsunamis that have just happened. We've been able to observe the situations where you get erosion, the situations where you get deposition, and understand that both of these are possible. Try to identify the conditions under which you will get sediment deposition. As the tsunami comes in, it will get sediment from the sand, from the sea, fine sand, and will deposit it inland. So it was not an easy. It was not, even to us right now, it looks obvious that yes, tsunami comes in, carries sediment, it's an obvious thing. But it was not. It was not up until 2 or 3 decades ago. It was not obvious at all. It took quite some time and work, both in hydrodynamics, understanding tsunamis in the field, and archaeological work, to be convinced that it is a viable hypothesis.
The archaeologists have had also problems to accept the new date of the Santorin eruption. And now the eruption is dated around 1613 before Christ. And I learned from the specialists in volcanoes that the eruption was much stronger than the specialists believed 2 decades ago. So this was an enormous eruption. Is it possible now to reconstruct the tsunami, the direction of the tsunami, and also the effect of the tsunami for the culture? Because as I understand it as an archaeologist, the Minoans based their force on the fleet and on the harbors. And as you mentioned, a tsunami is especially a problem for the harbors. So some questions. The first, how strong the tsunami was. The second, what was the direction of the tsunami? How can we think about the destruction and the effect on the harbors?
It's extremely difficult to actually reconstruct the tsunami, and let me explain why. The sequence of eruptions is extremely important. Whether you have pyroclastic flows that flow down or whether you have a phreatic eruption, it will make a big difference. My own view is that it's a phreatic eruption, that everything gets blown out and you have backfill water entering the caldera and you create the initial wave. In terms of the impact, there's no question that the Minoan harbors were completely destroyed. Having seen and having been in tsunamis in the last 20 years in different field surveys, I think that it looks very much like the impact of the 2004 tsunami had in Sri Lanka, or the impact that we saw in 2010 in Peru. Probably it was not as devastating as what happened in Japan in 2011, but if you think about Sri Lanka, coastal Sri Lanka, it was brought to a standstill in the ports. There was extensive coastal flooding, and if you have flood areas, of course, you have the seawater stays there. Now, reconstructing it and saying this is what happened, it's almost impossible. We have a tremendous difficulty in my part of the scientific community, which is the hydrodynamics, reconstruct events that took place last century. 1946 tsunami in Alaska. Big tsunami hits the island of Hawaii and kills about 200 people. The island of Hawaii is in the Hawaiian chain. It's the biggest island, hit the city of Hilo. In Hilo, about 200 people died there. Even though it happened in 1946, it started from the Alaska, from the Aleutian Islands. This is the chain of islands between, Alaska and Asia, and it's where the Bering Strait is. This is where the tsunami started. It destroyed a lighthouse that was about 35 meters up in the air. Now, the process of that tsunami that only happened 65 years ago is still controversial. How did it happen? Why is it so big? The earthquake was not very big. So we're trying to understand that, and I've been to Alaska twice trying to find eyewitnesses that are still alive from the 1946, try to get reports. What is the height in different places? What did they see? So try to reconstruct the event. So I'm mentioning this as an example to give you an idea. If we're having a hard time, and this is a hugely controversial event, the 1946. Again, this is only recently, and there's tremendous controversy. Imagine how difficult it is to reconstruct the late Bronze Age eruption. And I agree with you about there's no question in my mind that the date is 1613 or maybe somewhere in the bracket that has been found by the radiocarbon dating. Whether archaeologists, and a lot of archaeologists have a problem with that, I think we as in the physical science, we have to do a better job to trying to convince them that this is how it is. And maybe they'll have to invoke something else that takes place 110 years later. Maybe there was another earthquake in Crete, who knows? But as far as the whole combination of events, the volcano, the tsunami, the destruction of the harbors, it all fits. And it fits in a combination that is, in my mind, fairly uncontroversial. The only controversy, to come back in the beginning, that I see is the exact mechanism of the generation of the tsunami, whether it's the phreatic eruption or whether it is the pyroclastic flows. And exactly over what period of time does this happen? Over 2, 3, 4 hours, 8 hours? Of course, the slower the eruption is, the smaller, the tsunami. But that's highly technical, and this is for us in the volcanology and hydrodynamics community to figure out. Again, the fact remains that the tsunami was generated from the eruption, and it had tremendous impact on the coastal towns and harbors and trade throughout the Eastern Mediterranean.
So you believe, from your point of view, that such a huge eruption must have affected a tsunami which destroyed the harbors, go a little bit into the country, and destroyed a lot of the buildings at the sea. But isn't it possible to detect the deposits of this tsunami, maybe in Turkey, at the coast in Turkey or something like this? Is it possible to do this? Or has it been done?
It is possible, and people have done it. But again, if you look, you can take any individual study of tsunami sediments for Santorini. In Turkey, for example, there has been a recent study of Caesarea in Israel. There have been many studies in Crete. You can take any single study and tear it into little bits and say, this is not right. I mean, how come this could have been from a flood? This could have been from a different. So all of the studies and the sediment studies go. There's always, some questions as to the origin. I mean, could it have been from the sea? Could it have been from a flood? Could it have been a different, different event? But if you take them all together, what we would call in English the preponderance of the evidence. And it's impossible to have, there have been about 15 different sort of sites that people have looked for sediments. It's impossible for all 15 of these sites to be wrong in the, in the same way. So the preponderance of the evidence suggests that there is a tsunami, had substantial impact. It left its signature in the sediment record and in the archaeological record. So the question now is, can we put all of these, and this is actually my own research, can we put all these things together to come up with a better model for the leading way of the eruption that will then help us understand even more of the impact of the wave?
If you put all this research together, is it possible to get an idea how deep the tsunami go maybe into the river valleys and how powerful it was?
Well, this is the missing link. How powerful was the tsunami? So the problem that we have to solve is typically when you find a sediment layer, you find a certain sediment thickness. And you know what distance it is, from the shoreline. But from the sediment thickness that could be buried under 2-3 meters of, of soil, whatever happened afterwards, from this sediment thickness, you have to think how high was the tsunami that actually deposited sediment of this thickness, if you take everything else, and then couple that with all the other locations. And that's very, very difficult, and I haven't done it, I don't think anybody else has done it, but certainly from the sediment thickness, which is a distinct signature, we know that it's been there and gives us a certain idea of the distance. So we can take this as a minimum. If we find sediment from the Thera tsunami in different locations at a different distance, we can say, well, suddenly it reached here. So this is what we call a constraint. So it constrains our model. All of these hydrodynamic models are to try to understand what, again, the size, coming back to the size of the tsunami. Just think of the Eastern Mediterranean, and you're standing where Thera is, and I'm here in Crete, and this is the west coast of Turkey. And we have all these different points. We have to go back to you from all of these different points and then try to solve the problem. Ask the question, how big is the tsunami that simultaneously will produce sediment in that location in Turkey, in this location in Caesarea, in this location in Crete? And typically these problems, they're mathematical by their nature, they have infinite solutions. They were what we call ill-posed problems. Ill-posed because to have the well-posed problem, you have to have sediments everywhere throughout the entire Mediterranean, and then you would have a problem that is easier to solve. So for now, we're at the point of actually collecting all this, seeing how they fit, and trying to come up with models. And of course, the bigger the initial wave, the bigger the tsunami. This is different. What I'm doing is slightly different than what a lot of people are doing, which is you take the volcano, you take a certain mechanism for the volcano, go, this is what it is, and you calculate the impact. In my view, this is a hopeless approach. Hopeless because depending, as I said, on the size of the eruption, the timing of it, you can agree on the volume of the eruption, but the timing is so important you can get any number you like. On the other hand, if you try to solve the problem, the inverse problem, with constraints everywhere around the Mediterranean, and then you go back, you figure out an initial wave. If you know the initial wave, you can figure out the impact, in a way bypassing the question of the timing of the eruption, because what I'm trying to get out of is the size of the initial wave. Because once I know that, then I can go propagate it. Now, I've done the inverse problem, I've come to the Santorini, I found the size of the initial wave, I can take it back and figure out the impact in many places. For example, an interesting story, but the dates don't really fit. If you take the phreatic eruption, the mechanism through which the magma is thrown out, and you look at what happens at the impact of the wave in Egypt, and if you want to interpret the story of Exodus fairly liberally, and a lot of archaeologists think that the Exodus didn't really take place in the Red Sea, but in a tributary of the Nile Delta, then the leading wave from Santorini would have caused, if it's a small river, for the water level to drop down for a few minutes. And as the water level drops down, if you have a river, the river bed gets exposed and people can actually walk across. And we saw this most recently in 1994 in Mindoro in the Philippines. So if the story of the Exodus were willing to sort of play with it in terms of when it happened and not to take it literally in terms of it happened in the Red Sea or it happened in that particular, and again, we have the problem with the chronology. But if we take it a little bit more liberally, as if by saying that someone had observed something like this happening around that period of the water level in the river dropping and people being able to walk across, then it starts making a little bit more sense that there is a physical explanation for the miracle.
Could it be that by an enormous tsunami, maybe as we see it in Southeast Asia, that the river Nile, for example, fall dry for a moment?
Not the river Nile, it's too big, but small rivers, yes. We saw this in 1994. There was a small tsunami in the island of Mindoro in the Philippines. Mindoro is just south of Luzon. Luzon is a big island in the Philippines where Manila is. The earthquake was not very big, about 7.5. The tsunami in most places about 2 to 3 meters, not a big tsunami. I found a fisherman, and there's a small river there, maybe about the width, about 50 meters or so. There was a fisherman there that just told me that he was standing there, felt the earthquake, and what he described as a few minutes later, he saw the amazing thing, the river emptying. And then he said that for the first time in his life, he saw how the river was underneath. And he could walk across. He was about 1 kilometer inland from the sea. Of course, again, this was only possible because the river was so small and so narrow, and the earthquake, the leading wave from the tsunami, caused the riverbed to empty. And in fact, it was him that basically told me, it was just like in the Bible. I said, yes, of course, just like in the Bible, because the man just actually saw what others would have interpreted as a miracle if they had not associated with an earthquake. So it is entirely possible, yes. But we have to get the dates right.
So there's no question that with the volcanic eruption is a tsunami, but we don't know how high, how destructive it was.
There's no question there was a tsunami, a destructive tsunami. What we do not know yet is how big and how destructive. I compared it earlier to what happened in Sri Lanka, simply by seeing and having worked with archaeologists in Palekastro, and just seeing the debris layer there and looking at amnisos, and very, very qualitatively. There's no question it was a destructive tsunami. Now, I do not think that it was as big as Japan in 2011, clearly not. But this is something it's out there. So we need to work to try to and I'm working in this direction, trying to use all of the sediment studies that have been done to figure out what is the size of the wave, which is a very long and tedious process, because as I said again, the problem is ill-posed. Mathematically, you work on this and you find occasionally some huge waves, and in one particular direction they don't fit in another direction, and from that maybe try to see what happened in the volcano. So I'm taking a completely different way than a lot of people who model it, who start from the eruption and model find out how big the tsunami was.
Is it possible to do a modeling in which direction the tsunami goes? Maybe does he affect it does he affected Egypt, Israel? Does he maybe affected the west side of Greece or South Italy, maybe Spain or France? Had we an idea about this?
There is, in my simulations, it's quite clear that it affected the north coast of Africa, all the way clear to the west end of Libya. How big it, again, it's just a question of the size. If you take my current thinking is now that the initial wave of the tsunami was of the order of about 20 to 30 meters, but that's actually the deep sea, not near the coast. That's at the depth of water of about 400 to 500 meters. But it's a fairly short tsunami. Yes, the impact would have been felt throughout the Eastern Mediterranean. Whether it reached all the way to modern-day Spain and Morocco and Algeria, that's something we just have to see. It's not. It is easy and it is not. It is easy in the following sense: you can put any numbers in a computer model, and you can get anything you like out of it. I can create waves from Santorini that reach outside the Pillars of Hercules, and they go in, they impact, and I create waves that are hardly noticeable in Crete. So, and there are very few constraints in terms of the volcanic eruption. So we really need geoarchaeological work to get more of these, they call constraints. If we had, for example, a constraint in Italy, that would limit the options on the eruption of the almost by a factor of 1,000. Because geographically, it's in a different area that we don't have points. You see, all the points that I have is Crete and Western Turkey. If I get one point somewhere there that tells me something about the tsunami, we will be very, very close to the final answer, to the best answer.
Plinius the Younger mentioned that Plinius the Elder tried to rescue people from the eruption which destroyed Pompeii, and he mentioned that seas going back, you know, from the beach. Could it be that also the eruption of the Vesuvius affected a tsunami?
If there is this description, and it's quite clear that this was a tsunami, the reason is that depending on the mechanism of the eruption, quite frequently you get a wave that causes the shoreline to retreat. And that is probably what he's referring to. I mean, any unusual part, of course one would have to think, I mean, if it's a meteorological tsunami, but if it is that close, and there's no question it's a direct effect of the eruption. It's a very interesting description, because this is the first time that I hear it, and I'd like to read it. But the way that it sounds, it's definitely a tsunami.
We will find it. So we all remember the large tsunami in Southeast Asia in December 2004. Was this tsunami unpredictable? And in general, is there possible to predict tsunamis? And at the end, how does it change the science of tsunamis if you see it? Because I had the feeling that a long time the people don't really believe in how destructive tsunamis can be. So I had the feeling that the TV pictures of Japan and of this Southeast Asian tsunami changed the view on tsunamis. Suddenly the people are interested in.
Yes. There is no question that TV images, and just seeing it live, particularly in a place like Japan that's highly industrialized and fairly heavily populated, gives us a real idea of the impact of it. Of course, in most cases, tsunamis happen in areas that are more rural, not as densely populated. But the Indian Ocean tsunami, coming back to your first question, how predictable it was, with hindsight. I mean, as some people have said, it's extremely difficult to predict earthquakes, particularly before they happen. But of course, in many countries in the world, particularly in Europe, and I mean, we saw this in Italy, and we see it many times in Greece, and I mean, also in Japan, people are, I mean, it's a hobby. People try to predict the earthquakes. And of course, predicting a tsunami, typically you have to predict the earthquake first. If we were to predict, let's say, a tsunami from a volcano, that's easier, because volcanoes typically give you a few months, a few weeks notice of that something is likely to happen. And then you can make a forecast. When it comes to a tsunami, you have to be able to predict when the earthquake takes place. And I don't think we're anywhere close. But I think the real progress that has been achieved in the Indian Ocean and has been in terms of tsunami warnings. Once an earthquake happens, now we're in a position to give a warning, and I mean, a German-Indonesian initiative has been a big part of that. Has really helped establish a warning center in Jakarta to prevent, or at least give a warning. Whether it's able to prevent a catastrophe, this really depends on the local people in every country, to what extent they can understand the message and take measures. But I think in terms of science, we have been progressed tremendously in the last 7 years, since 2004, in terms of providing warnings.
Okay, thank you very much for the lecture. And I wish you a good conference.
Thank you very, very much for inviting me. This was a great opportunity. Thank you.